Welcome, everyone, and thank you for coming to our second day of the Juneteenth conference. This is a pretty loaded weekend. We have 2 days of our conference and then off to Father's Day tomorrow. So hopefully you're enjoying your weekend. Today, we're excited for our speaker lineups and our keynote and our town hall. But before we get started, let's observe a 8 minute and 46-second moment of silence in recognition of George Floyd, of Breonna Taylor, and of so many other lives that we know and that we can't name. Thank you for joining me in tribute of our our fallen lives. Um, Thank you also for indulging me in these moments before we start and after we end. I'll have one more conversation with you at the end of the show, uh, but right now I wanted to go over a few things as well. Um, so I didn't touch on this yesterday, but journaling uh, was a major part of what brought this conference to life. It was a reflective moment. I use my journaling almost as meditation to intentionally detach from uh, all of the electronics that I'm constantly in front of and to take time and write by hand. My handwriting has improved incredibly over this time. Uh, Without my journaling practice, this I wouldn't have had the moment to reflect and to create this. Um, I also had an early start in tech. My first computer uh, was a Tandy 1000 that my grandmother brought me um, when I was 8, and I'll talk about that later at the end. But basically, with that investment, um, my spark ignited for technology, and I'm so happy that um, we're able to provide a spark for so many other people as well from this. My first year of college, our Black History Month convocation, the theme was fear of a black planet. And it wasn't just in terms of fear from others about a black planet, it was fear of our own success. And like Danny said, we can't get in our own way. We need to be able to dream. Like I said, the fear of claiming a black space almost got in our own way. Um, I put some numbers down around progress in America, especially black milestones. In 1619, the first slave was brought to this country's shores. 246 years later was Juneteenth, 1865. Since Juneteenth, this was our 155th celebration of Juneteenth. But between Juneteenth and the Civil Rights Act was another 103 years in 1968. Today is 52 years after the Civil Rights Act, and we're in the middle of another movement. What should we be pushing for in this movement? I suggest we should push and pressure and hound that the 13th Amendment be revised or a new amendment be made that removes that exclusion of slavery for prisoners. There are far more black men, black women, and even black children shackled in prison than there ever were slaves at the height of the slave trade. Their labor is being bought by private industries and being used for profit. When BP Oil promised to use local labor to clean up their oil spill, they did not use free people. They used slave labor from prisons. We're not going to call it prisoners because from the start of slavery in America, we've used dehumanizing terms to make slavery acceptable. They said they're savages. They said it's a white man's burden. They're bringing them to a life that is better than what they had before. All of these were lies. Now we're saying they owe a debt to society. Realize this: at the end of our justice system, there is a profit to be had. And as long as there is a financial reason, a financial benefit in our justice system, how can we say it's justice? At the very least, it's suspect and at the top of it, it's corrupt. We have cases of judges that were selling children off to their buddies' reform centers, and we have so many instances of where people are being paid 50 cents a day to farm to make cheese, goat cheese, where it can be sold at Whole Foods for $10 a pound. That should be our number one goal right now. That would bring the most reform, remove the financial benefit, and it all falls down. Our police state is basically the current slave patrol grabbing Black lives off the street under false pretenses and putting them in shackles and making them work to continue building America's economy. They say that it's immigrants who are stealing your jobs. No, it's private prisons that are stealing jobs and given unfair competition. They're given unfair competition in the market by paying prisoners 50 cents a day to do the work that another farmer might pay more. That should be our number one priority right now. And there are more, but this would be a huge fix for what's wrong in America. Thank you for indulging me in this time. I'm going to give our keynote speaker her due time, and I'd like to thank her as well for letting me carve a piece of her allotted time. Have a great day. Enjoy the conference. Thank you for joining me again. Thank you for joining all of us from the whole team.
All right. Thank you, Michael, so much for sharing your thoughts and ideas. I have the privilege and honor of welcoming Angie Jones as our keynote speaker. I'm so excited about this. I have been following her work and all of her technical contributions in the community for a really long time. When I started kind of getting courage to start speaking and building blogs and content, I saw her and I was so excited to see another Black woman that looked like me, that was out there commanding audiences and just changing the world. I mean, when Angie speaks at a conference, like it sells out like Beyonce World Tour. So she is amazing. If you don't know Angie Jones, she is a senior developer advocate that specializes in test automation strategies and techniques. She shares her wealth of knowledge by speaking and teaching software conferences all over the world, as well as leading the online learning platform Test Automation University. So without further ado, I am so excited to introduce Angie Jones as our keynote for this morning. Angie, take it away.
Thank you so much. Hello, everyone. Okay, great. So imagine a scenario where you walk into your favorite department store. You've just gotten a little extra cash or bonus from work, or maybe some people have given you some Juneteenth donations. So you have some extra cash in your pocket. And you begin picking up all sorts of items in the store, and you take them back to the dressing room where you begin to try these items on. The things that you like, you go ahead and you place them in one column. The things that you don't like, you put them in another pile. And the things that are so, you're not so sure about, you put those in a third pile. Now, imagine that mirror there is actually a smart mirror. And it's been observing all of the actions and decisions that you've been making. And now it's even able to recommend to you other items in the store that it's sure you'll like. Those items even have little buttons there. You can click them and a sales clerk will bring them to you in your size. Pretty cool, right? What's really cool about this is that the technology for this exists today. So, my question to you is, how would you test this? Take a moment. Think about that. Would you even know where to begin? When working on teams that are employing machine learning within their applications, I often hear the team say something like, "Oh, we don't need to test this one. This is the machine learning feature." And everyone, even the testers on the team, go, "Oh, okay." And they carry on with their lives. Now, I don't know about you all, but I watch the news and I know that these algorithms are far from perfect. And yet, for some strange reason, we blindly trust these systems as if they are this all knowing black box of perfection. At the end of last year, David Hansen, he's a well-known technologist, he publicly shared an experience he had with Apple Card. And David and his wife, Jamie, both applied for Apple's credit card. And while they were both approved, David was granted a credit limit 20 times greater than the one Jamie was granted. Now, you may be thinking what a lot of the commenters in the thread were thinking, David must have better credit or higher income or some other factor. Nope. David and Jamie, they filed their taxes jointly. So on paper, their income is one and the same. They called the customer service reps and they swore that there was absolutely no discrimination because it was the algorithm, right? So the Apple reps, they actually urged the couple to check their individual credit scores, and as they shamed Jamie, basically insinuating that surely her credit must be low because there's, no way that there's any type of bias or anything. So they pay to get their credit scores, and lo and behold, Jamie's credit score is actually higher than David's credit score. So of course, they call Apple again and they're like, "Hey, look, we're sure you all aren't intentionally discriminating, but your algorithm is sexist. And given the factors that are considered when determining a credit limit, if anything, Jamie should have been given a slightly higher limit than David was getting." So it didn't make sense. It made absolutely zero sense for Jamie to be given 1/20th of the credit limit that David had. The Apple reps, nor their supervisors, because this was escalated, could wrap their minds around how technology could possibly be wrong. Eventually, the Apple employees, they got tired of arguing and going back and forth with these powerful people. So they upgraded Jamie to VIP status to match David's credit limit. So I was reading this thread. It was fascinating. And I got to wondering, how would you test this? Because it seems like either Apple is like the other teams I've seen and they skip testing their machine learning algorithms because they have blind faith in them, or they're not testing with diversity in mind, which is why I'm always baffled when people naively ask, why do we need diversity in tech? I mean, it's not about just giving women and minorities jobs for optics' sake. It's because diverse teams build better products, period. And you can sit on your high horse and pretend that tech is not political, but the stuff that we build affects people's lives. And with great power, what comes great responsibility. So we treat machine learning as some futuristic concept when there are many applications right now that employ some type of artificial intelligence, applications that we are using on a daily basis, like Netflix, for example. Do you know that your Netflix homepage is personalized just for you? And this is driven by machine learning. So every recommended video that you see on Netflix is selected by the algorithm. And 80% of what we watch is from the recommendations. So this is pretty important to Netflix's business model that they get this correct. But what does correct even mean in this sense, right? How would you test something like this? I know myself better than anyone else, and I can't even say if my Netflix recommendation page is correct or not. In fact, I went and took a closer look at my Netflix page just to see if anything jumped out to me as being incorrect. Without having seen these shows, I don't know, But there was this one. This is the recommendation for Beyond Stranger Things. Now, I don't know what that is. So I Googled it and found out that it's a show that basically talks about Stranger Things, the popular show Stranger Things, right? And when I was reading, it explicitly said, don't watch Beyond Stranger Things if you haven't seen Stranger Things, because they're going to have spoilers, right? The thing is, I've never watched Stranger Things. So this seems a bit off, but how can I verify this, right? So again, the question, how do you test this kind of stuff? I used to work at Twitter, and one area where we used machine learning was to detect and classify spam before it's even reported. So let's say you had a tweet like this, and this says, message us if you're looking to buy some followers, $2 per 1K. Now, I think we can all agree that this is spam, but how do we know this? Is it because of the words that are used? Because if I take this tweet, which says, hey, wannabe celeb, you have a total of 2K fans. Why don't you go buy some followers? Same kind of verbiage, but this is not spam. Rude, but not spam, right? So how do you go about testing these sorts of things that you're building? Are you familiar with IBM Watson? It's IBM's artificial intelligence engine, and it can do all sorts of things, like make brownies. So I went to Grace Hopper conference a couple of years ago, and IBM had a booth there, and they were giving out these brownies that Watson had come up with the recipe. Now, what Watson did was analyze thousands of brownie recipes and came up with what it considered the world's best brownie. Now, me being the nice person that I am, I went ahead and took one for the team. I tested this out, so you don't have to worry about testing it. I can let you know that this algorithm works, okay? Best brownie I've ever had, hands down. But it's not all fun and brownies with Watson. Watson also does more serious things, like recommends personalized treatment plans for cancer patients. And it does this by analyzing their DNA, as well as millions of pages of medical literature and clinical trials. And I think we can all agree that there's not much room for error here. But how would you test it? How would you test this? Now, theoretical talks are cool and all, but that's not really my lane. You see, I work in the trenches, and I had to actually answer the question of how do we test these machine learning algorithms that we're building? So I love to share my real world experience with you today. Cool? Cool. All right. So I had the opportunity to work on this exciting project that utilized machine learning. The product was an advertisement recommendation system. And the way it works is e-commerce systems would use us to host their inventory of ads. And when they would engage with one of their customers, They would query our app to determine what's the best ad to show this customer in real time. Now, much like the advertisements we see when we're surfing the web, they're tailored to us based on our browsing habits. This software actually allowed the businesses to show specific product ads to their visitors based on characteristics of that person and their current context. So this type of algorithm isn't entirely new, but what gave us the advantage over the competitors was the coupling of the real-time decision making along with a learning algorithm that promised to help the businesses make better decisions or conversions over time. So I was tasked with automating scenarios to verify if the learning algorithm was working as intended. And while this was exciting, it was also very scary because I had no experience with machine learning whatsoever. In fact, when I got this task was the first time I had ever even heard the term machine learning. So I had quite a bit of homework to do. Now, when testing software, I'm accustomed to working on scenarios where the expected result is exact. For example, let's say I'm working on some typical e-commerce site. I add a product to the cart. That product was $20, right? I increase the quantity to 3. Subtotal should be $60, right? So this is predictable. This is exact. This is testable. I quickly discovered that with machine learning, there is no exactness. So there's a range of valid possibilities that could occur based on what the machine has learned and how it will utilize that information for future decisions. So the first thing I needed to do was to learn how this algorithm learns so that I can determine what's that range of correctness. Now, there was one guy, we'll call him Resident Expert, and Resident Expert was responsible for the machine learning features. So I talked to Resident Expert, to try to get some insight into what triggers the machine to learn, how does it learn, how does it use what it's learned, to make decisions. Now, Resident Expert, he's one of those tech bros who, kind of talks over your head. You know the type. You might even be the type. But Resident Expert, he hit me with like a bunch of jargon and mumbo jumbo that I just didn't fully understand, right? So I heard what he had to say, but then I also took a deep dive into the code, try to get some clarity on how stuff works. So I learned a few important things. I learned that when the third-party e-commerce system wants to show a user an ad, they sent us an API request with information about the customer's demographics, right? We would then respond back to them with what's the best ad to show this person. When we give them that, they present the ad, and if the user interacts with the ad and it turns into a conversion, they send us yet another API request, basically saying, here's what happened. The user bought something or they didn't. And we call this accept or reject, right? Now, before using our system, of course, the system hasn't learned anything yet. So we'll randomly just show ads to the people. And as there are more and more interactions, then our system begins to detect patterns and behaviors for certain demographics. And that's where the learning comes in, right? So 1 or 2 little interactions is not enough. You need lots of interactions, thousands, maybe multiple thousands for the system to properly learn. And what our system learn is stored into what they call models. So these are like little knowledge bases, right? And it consults those knowledge bases or those models in order to make decisions. All right, so that was a lot. I learned a lot there. So I had to give the system something to learn, or in other words, train the system. So I started with this very simple scenario. where I wanted the system to learn that women are more likely to buy dresses and men are more likely to buy pants. Now, remember, we need quite a bit of interactions for the system to observe the pattern. So I wrote a script that simulated API requests for 2,000 unique customers who identified as either male or female. And then I randomly generated the gender of each of these customers. So there was always like a 48 to 50% split of one customer gender versus the other. And my goal was for a vast majority of women to buy a dress after being shown the dress ad, and a vast majority of men to buy the pants after being provided with that ad. Now, I didn't limit the inventory to just the dress and the pants. Instead, I did 5 different products. So dress, pants, and then scarf, gloves, and belts. And since there were 5 ads, the chance of a woman being shown the dress ad or a man being shown the pants ad was 20%, right? That's random. And remember, the system doesn't know anything yet, so there's no models or anything just yet. To make this more realistic, I skewed the conversions a bit so that it was more like a 65% conversion rate versus 100% of women buying the dress when shown and 100% of men buying the pants. Because the last thing we need is a system that assumes that all people of a certain demographic behave the same way. Okay. So that's the math part. This essentially ended up with a pool where roughly like 1,000 customers, or 1,000 of the customers were women. And then of those women, 202 of them, which you see in that second column, 202 of them were provided with an ad for a dress. And of those 202 women, 133 actually went on to buy the dress. The rest of that column shows that a few of the women made random purchases based on the ad they were shown. So 3 or less for all the other ads. A similar pool was generated for men in pants. So we see 196 men saw the pants ad, of which 128 of them went on to buy it, and 3 or less for all the other products. All right. Cool. So we got it all set up. We've simulated the training. So it was clear to me that the system should learn that the women are more likely to buy the dresses and the men are more likely to buy the pants. And having learned this, I expect that the system will now offer women dresses more often and offer men pants more often. However, I got to thinking, like, what does more mean exactly, right? I wasn't quite sure, right? And I need to write an assertion here. I'm in code now. I can't just like say, oh, I don't know. I need to actually put something down. What is it that I'm expecting? So I went to talk with resident expert, and he couldn't even tell me like what's the exact answer here. He couldn't even distinctly give me a range to expect. So this was really interesting to me. Now, I'm no statistician or data analysis, so I resorted to using the PAC method. The PAC method is plain old common sense. And plain old common sense tells me that if 20% of the women were shown the ad for the dress when there were no models in place, then after the system has learned, I expect more than 20% of the women to be shown the dress, right? And I expect the other 4 ads to be less than 20%. That's about all I had, right? And I expect that same conversion for the men with pants. So now that I've trained the system, now that there are models, I executed my script again, but this time with 2,000 new unique customers. And I captured the ads shown and the purchases made into this new data structure. And I had my code to compare these 2 data structures, so the one before learning and the one after learning, to see what the results were. So before learning, 202 women were shown the dress ad. And then after learning, 890 women were shown the dress ad. So yay, it learned that the women prefer the dresses. Great, looks good. Then I looked at the poor guys. So 196 men saw the pants ad before the system learned anything. And then after the system was trained, only 59 saw the pants ad. So less than before. But not only that, it seems that 874 men were shown the dress ad, even though only 3 men actually bought the dress after seeing that ad. So that doesn't seem right, you know? So something was wrong. And of course, I began wondering, what did I do wrong? Right? So being a novice to machine learning and all, I was sure it was my fault. Did I not train the system properly? Maybe. So I cleared all of the models that the system has stored. So basically, I erased everything that the system learned and I reran the test. This time, I did get a different result. This time, the men were shown the pants more often after the system learned, and I got a little hopeful, but so were the women. They were shown a whole bunch of pants as opposed to the dress. So very, very strange there. And I began to mumble to myself, like, I clearly don't know what I'm doing. I don't know why they put me on this project. I don't know diddly squat about machine learning, right? So I started to just look through my code line by line. I'm going through this code. I'm trying to find my error. I increased the number of API calls from 2,000 to 10,000 because remember, maybe it just didn't have enough to detect a pattern. It needs to have enough data to be able to detect the pattern. So crank that up to 10,000. Same result. And it would flip-flop. So sometimes it would be the dresses that were shown to the men and women. Sometimes it would be the pants. So I printed out the results of my data structures, the before and the after the learning, so I could see what's going on. Let me look at this. And aha, I figured out what was happening. Now remember, I was randomly generating gender in the code, right? So it was never 50-50. It would be more like 49, 51%, you know? Something like that. So I noticed that whichever ad led to the most conversions during that training period time, that's the product that the system learned was the most favorable. And then the second most popular one would be shown more than the random 20%, but still less than the most popular ad. So it became clear to me that the customer demographic was not being considered in these decisions. And that was a bug. A bug in machine learning? Yes, friends. Your girl Angie found a bug in machine learning. Now, writing up this bug report, unlike any bug I've ever written, I'm used to giving a little description of the scenario, give you a little one-liner of the expected result, another little one-liner stating what's the actual result. And if I'm feeling real generous, I might throw in some logs, some screenshots. But with this, there was no one-line expected result, right? I had to basically write a doggone book, including detailed information about my scenario, about how I trained the system to support that scenario, why my expectations were what they were, and how did I go about verifying those things. So this took me hours to write up this bug. And I opened it with the highest severity, right? So resident expert, he gets the notification, he takes a look at the bug report. And y'all won't believe what this man said to me. He said, well, It works on my machine. And he closed my bug report. So I was crushed. I already was dealing with that imposter syndrome. I'm in a situation that I don't feel I'm, qualified for. And I thought I had made sense, and I was so excited. I had found this bug in machine learning, and he said it wasn't. So, I sat with that for a few minutes, and, I had to get over it. I humbled myself. I went to his desk and I said, okay, great. It's working on your machine. Beautiful. Can you show me, what you did? I'm sure I probably set something up wrong. And he goes, well, and he proceeds to start talking all of this theory about machine learning, and he's throwing all of this fancy jargon and his mumbo jumbo like he always does. And he never showed me any setup. He just attempted to assure me that learning works. It just works, Angie. So at this point, I had enough of this day. I went home, tried to get some rest, but I could barely sleep for thinking about this bug, right? So I went back the next day and I started looking at my code and my setup again. I got my fresh eyes. Maybe it'll jump out at me. So I did the same thing that I did the day before. I'm deleting the models. I'm starting over. I'm looking at all the lines of code. I'm increasing my number of customers, all of this. No matter what I did, the system just was not learning based on demographics, right? Whichever one was the most popular, it just was assigning it to those people, no matter gender. So I called my team lead over and I gave him my whiny rant about how nothing is working. I'm sure I'm doing it wrong. I don't know why y'all assigned me to be on this project. And he said, Angie, stop it. You're not wrong. You've done the research. You've done the work. And you know it just as well as anyone else here. It's a bug. So I reopened the report. Resident expert, he didn't close it this time, but he did make some comments in the ticket, and he put all his fancy jargon, he put all of his mumbo jumbo, and I simply replied, it doesn't work. So the bug just sat there like for weeks until it became time to release the feature. Well, you can't release the feature with the highest severity bug open. So the product owner called a meeting with resident expert and myself, and the meeting went something like this. So resident expert, he began to mesmerize the room with that fancy talk. And let me tell you, when this guy speaks, people listen. He sounds so smart. And he's throwing around these fancy words and this high-tech jargon, which basically summed up to blah, 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 learning works, right? And then it was time for me to plead my case. Well, I know I didn't have a shot at matching his wit when it came to this topic. So I decided to take a different approach. I said, okay, here's what's going on. Let's say we have an e-commerce business that buys our service. They have a website, and we're providing them with recommendations on what to show their users. The men, they are buying these pants like hotcakes with a 65% conversion rate. And as we're observing this, we decide it would be a fantastic idea to instead show all the new guys who come to the site a dress ad over and over again, even though they're only buying this 2%, less than 2% of the time. So by using our service, this e-commerce business is losing a ton of money, and I'm sure they'll end up ditching us when they realize this. But hey, do what you want. and I rested my case. All of a sudden, I had everyone's attention. Product owner immediately turns to resident experts like, no. Run her scenario, her exact scenario. Run that on your machine. Let's see it. You got to do a demo now in this meeting. And so he goes, all right. Tap. He gets what he needs, gets my data and all of this stuff, and he runs it. And guess what? It doesn't work. So he turns red in the face and he holds his head with shame and he says, I don't know why I doubted Angie in the first place. And I'll admit that felt pretty good. So what did I learn from this experience? Well, in this case, hard rules such as the exact results must be known in order to test this stuff had to be revisited and challenged, right? And I feel like this is where a lot of teams are going wrong. They aren't really considering that, hey, it's necessary to test these algorithms. The techniques you use to check if your button works, that's not going to necessarily fly over here when we're trying to test machine learning. Right? But that doesn't mean you get to skip testing this stuff. Yes, the testing will be more rigorous, but that's the cost of utilizing such software. I also learned that the need for automation became much more apparent as thousands of customer transactions needed to be simulated and analyzed. So sniff testing the app manually, that doesn't do anything in the case of machine learning. Your little basic unit test, that's not enough. So my test code was pretty complex, but it was able to detect this major bug and save us from embarrassing ourselves in the market. I learned that simply knowing how to code wasn't enough. So resident expert, he knew how to code and he knew machine learning. Yet he was ready to ship this software without the most basic of scenarios working. There is a real need for thoughtful and critical testing of these applications. And finally, no matter how smart machines become, having blind faith in them is not a good look. Plain old common sense can still trump an algorithm. I use common sense to get the product owner to get past the lure of resident experts' fancy jargon. David and his wife Jamie, they used common sense to convince Apple that their algorithm was sexist. And while we should embrace new technology, it's imperative that we as engineers, as technologists, that we not allow others to convince us that any software is beyond the point of needing testing. We must continue to question, to interrogate, to advocate for the human customers that we serve. This was just one example of machine learning in action. If we ship this as is, the worst that would happen is we lose some money, right? In business, that sounds major, but we're using AI for much more, where it's literally life and death. I went to OSCON a couple of years ago, and I heard Paul Fenwick speak about the trolley problem. And I love how colorful Paul is. So instead of me doing this a disservice, I'm going to let Paul talk here.
As you all know, for anyone who has read anything about autonomous vehicles or spoken about autonomous vehicles, it is required by law that if you are going to give a talk about one of these things, you have to mention this thing called the trolley problem. So I'm going to get that out of the way right at the start. So I want you to imagine that autonomous vehicles are real. And it's really interesting because 2 years ago when I gave this talk, people were like, oh yeah, they might happen, they might not. People would keep telling me that autonomous vehicles would be a long time coming. Now we're starting to see them on the actual roads. So I want you to think that forward into the future. Imagine that you have really smart autonomous vehicles and you have this situation. You have a cliff face with a single lane that's been carved out of it, And you have a car with an occupant, there are no longer any drivers, who was in that vehicle driving along the cliff face. And there's no place to swerve, there's only one single lane. And quite unexpectedly, a child runs out into the middle of the road chasing a ball and trips. And the car is driving at such a speed that it is unable to stop in time to avoid a fatal collision. Now, if you're wondering how could this possibly happen, the child forgot to carry their personal tracking device, so the car was not aware that they were around the corner, and they were hiding behind some sort of terrain. They were behind a rock or behind a tree. The car did not see them. So the car is going to hit this child. The child will die if that happens. But the car has a choice. Rather than hitting the child, it could choose to throw itself off the cliff. And it's a long, long way down. It would be sacrificing itself and its occupants to save the life of the child. And of course, the question is, should it do this? And some people will say, yes, it should. And some people will say, no, it shouldn't. And lots of people will say, oh, gosh, that's a really hard question. How about we talk about something else? That's the most common thing I get, people telling me that, no, this is not possibly something that could ever happen. But let's pretend there is a child there. And you might say, maybe not. But what if there are 2 children in front of the car? Or what if there are 5 children in front of the car? I would hope at some point there is a sufficiently large number of children's lives at risk that you'll say, yes, the car should throw itself off the cliff. It should sacrifice itself and its occupant. So this is like the standard introduction to machine ethics, trying to convince machines to act in an ethical way. And I find this particularly interesting because we can't agree with what human ethics should look like. I have these interesting questions as to, how we should act and what is actually considered to be good. And trying to talk about a machine in this sense is really interesting.
So, of course, my question is, how would you test this, right? It's not about math anymore. We have life and death here where we have to make these decisions. As much as we don't want tech to be political, we are making these powerful things that are impacting people's lives. So I ask you, friends, to please just be aware that as technology evolves, it is our responsibility to make sure that we evolve to the point where we can test this. Thank you.